In contrast to determining the domain of a rational function, where we look for the denominator to equal 0, when we want the zeros of a rational function, we're instead going to look for the numerator to equal 0. If you think of any fraction that you've ever worked with, the only way that a fraction can have a value of 0 is if the numerator is 0. The denominator is not allowed to be 0. That's the work that we did with the domain, and that's what disqualifies a function or a fraction from even existing. So if we're going to look for the zeros, that's when we want this function to have a value of 0. That's when we want this entire thing to equal 0. But the only way that's going to happen is if this numerator polynomial itself is 0. We're not worried about the bottom. We're looking primarily at the top. Now, there will be some weird situations that we'll look at in later lessons where what if there's overlap between the zeros of the numerator and the zeros of the denominator, and those have some interesting applications to the graphs. But for right now, for the purposes of what we're looking at, the zeros of a rational function are determined by looking at the numerator equal to 0. So similar to the skill that we used for the denominator, we're just going to go back to last module and think, how did we solve these? Well, our easiest route was always just factoring and solving. This is a quick factorization of x minus 6 and x minus 2, which gives us zeros at 6 and 2, which means regardless of what the graph of this might look like, and we looked at the fact that there were two numbers that weren't in the domain of this function, that's going to have an impact on the graph. We know that it's going to cross the x-axis at two different places. That's 6 and 2. Similarly, for our second polynomial, our second rational function, we're again going to look at the numerator. We're going to set the numerator equal to 0. And we're going to factor. We have two solutions, x is equal to 4 and x is equal to negative 1. And if we graph this polynomial, we would anticipate that it would take we wouldn't anticipate the shape at all necessarily at this point, but if we were to graph this, we would know that it would cross the x-axis at x is equal to 4 and x is equal to negative 1. Contrast this to the last one where we had special considerations for the domain. Here we don't. We know that this denominator is always going to be positive. With a domain of all real numbers, we expect all of the values of x to have a point at them. We just know that when x is equal to 4, the value of the function will be 0, and when x is equal to negative 1, the value of the function will be 0.